So for square A, B, C, D, if a point is chosen at random from the labeled points A, B, C, D, E, F, G, H on the square, what's the probability that that point is closer to point A than C? Again, let's break down the problem. We have a square labeled A, B, C, D with a bunch of other points, and we're going to choose a point at random from this set of points, which are all the points on the thing, and we're looking for the probability that that point is closer to A than C. Alright, so probability. The probability that chosen point closer to A than C, which is a long way of writing it, is equal to, we have to look at the total possible, what we call outcomes, things that can happen, and we're going to look at the total desirable outcomes, the ones that meet what we're looking for. So for example, if I chose point E, is E closer to A than C? Well, if it's a square, I'm going to assume that H and F are midpoints, although that's a reasonably big assumption, but nonetheless, regardless, when it's on the line, E will be closer to A than to get to C, either on the perimeter or directly through. So E, for example, is a desirable outcome because it's closer to A than E. So let's look at the total possible choices. So the total possible choices are, I could have picked A, I could have picked E, B, F, C, G, D, and H. So that is 3, 5, 8. So 8 possible locations. So my denominator, total possible outcomes, is 8. Now, points closer to A than C. So we'll circle these in different color. Blue will mean closer, red will mean not. So is A closer to A than C? Yes, it's on A. H is closer, E is closer to A than C, whereas C is closer to C than A, as is G and as is F. Now D and B are the same distance from A and C. So the question is it desirable? What is the probability that a point is closer to A than C? So if it's not closer, it's not desirable. So we're going to say that D is not closer to A than C. B is not closer to A than C. So we're looking for these 3. 1, 2, 3. 3 out of 8. So the probability of picking a point that's closer to A than C is 3 out of 8. The probability of picking a point that is equally close is 2 out of 8. And to get one that's closer to C than A, 3 out of 8. Bonus, can you draw a line where the probability of selecting a point that is the same distance from A as C? Well, we know that points B and D are on that line. And, the midpoint of A and C, the point halfway, would be in the center. So, if I could draw a straight line, that would be the line where all the points on that line are the same distance from A as they are from C. So that line segment we will call DB, or we can call it line DB.